Right, so we've got a very interesting fault today, and we're going to show you something very cool on how to find it. So we got a neutral to earth fault on this dishwasher socket. So we have the module switch for there, and the load side is this cable which is under the sink, and it has a neutral and earth fault. Now, we don't want to be ripping the whole kitchen apart just to find where the break in the cable or where the earth and neutral are touching. So we're going to use a bit of math. So the first thing we're going to do is link out the earth and the line in the socket. So we're going to work out the distance of us and the meterage of the cable. So this is what we're testing. This comes up as 0.07. So getting to the paper and doing some maths now, we write down 0.07 between live and earth. That is our R1, R2, as we all know. Now, this is where we need to get our head into the guidance note and look at the per meterage of the resistance of copper. So go to page 218 and we find it at 1951 is our value that we need. So we're going to do 0.07 divided by 19.51, which will give us the answer of, which is 0.0036. Now we have to move this 3 decimal places because this value was in milliohms and we want it in ohms. And this gives us a value of 3.6 meters. Now, we have to measure what our cable length is and work it out, see if it's roughly the same, if it works out the same. So we kind of know how the cable runs because I run the cable in, but more things were done after that, which you'll see further in the video. But we worked this out to be, I believe, 3.4 meters. So we go back to the drawing board and write that down so we don't want to be forgetting any of the results. So, like I said, 3.4 meters. So we're there or thereabouts to what the calculations are on how long the length of the cable is. So yeah, we're pretty much right there. Now what we're going to do is test the faulty cable, so the earth and neutral on continuity, and see what we get. So we get 0.05 on this end. And now what we're going to do as well, jump on the other end and see where we get on here. And it should either be more or less. So if we clip on, here we go. So let's see what we get. In this case, is 0.01. So that works out about right again, because if you remembered, we measured it to be 0.07 on the live and earth. So that kind of works out. So that's telling us from that socket to that socket, the fault is closer under the sink than it is by the modular switch. As you can see on there, so it's 0.06 on the one side and 0.01 on the other. So we know we should be looking towards under the sink. I know this is hard to keep up, but just try and stay there at the moment, bear with me. So we know we should be looking around under the sink, like I just said, but we want to work out what the meterage is and how far across we basically want to be drilling our back of our hole there, or where the point of contact is, or where the cables join. So we're doing 3.6 meters divided by 0.07, when I actually write it down, which is going to be 51 centimeters. So from the end of our point under the sink now, we're going to measure 51 centimeters, and we should be there or thereabout to where the fault is. Now I can only drill around there for now, so we're going to get there, see what's behind there. At this point, I knew I chased in the sockets, and there was a socket behind this cabinet. So additional work has been taken place, and a socket has been brought into the front of this cabinet, as you just seen at the start of the video. So I have now a strong feeling that behind this board is where the fault's going to be, that something's happened, the other electrician or whoever has done something here, and as you can see, it's coming straight through the blank plate. So it's obviously been either joint or the cable's just been brought straight through, which we'll find out in a minute. So after getting the blank plate off, it was quite apparent where the fault was. As you can see, these long screws had gone straight through the neutral cable, which I should get a closer look at now, and this explains where the fault is. So yeah, using maths, you can narrow down a fault like this and save a lot of time and a lot of damage when you know what you're doing. So make sure you wrap your head around what I've just explained, and if you want a better in-depth video of this, please check out David Savory. Done a video on this. If you type in David Savory fault finding, he'll help you out on there massively.